So hello my dear students and learners. In the series of data structures and algorithm, in my previous video I have discussed about the concepts of 2D array and how to deal a 2D array using pointers. Okay, now before going to discussing the linked list, we want to be familiar with two more things. The one is structure and another one is the dynamic memory allocation. So today I am going to discuss the concepts of structures in C language. Okay, so now before going to the formal definition of structure, I want to say you something that, for example, look at the board, that I have declared an integer variable x and I have initialized this variable by the value 10. That means when this line will be executed by the C compiler, what will happen? The compiler will allocate 4 bytes of memory, suppose from 1001 to 1004. If you are working in a 32-bit compiler, it will take 4 bytes for integer, and then it will associate the name x with this address 1001, and then it will assign the value 10 to this location. Now in the next line, if we write x is equals to 20, and after executing the second line, what will happen? The previous value of x, that was 10, will now be overridden by the new value 20. Okay, so what does it mean? That means a variable is not capable to store more than one value at a time. Okay, so if we print the value of x right now, it will only print 20, but 10 will not be printed. Okay, so that is the main drawback of a variable. Now we have overcome this limitation of a variable with the help of an array. Now using an array, what we are doing? We are being able to store more than one value at the same time inside a single variable name. Okay, but array has its own limitation, and the limitation is that if you want to store value into an array, all the value has to be of same data type. For example, I am declaring an integer variable a having size 5. So what will happen? The compiler will allocate memory for this 5 integer value. Suppose the memory allocation is starting from 2001. Okay, so for 5 integer value, it will take 5 4s are 20 bytes of memory. So from 2001 to 2020, so it will reserve 20 bytes of memory, and then it will store values into this memory. But all the values has to be of same data type. That means if you want to store values into this array, all these values has to be of integer type. That means you can store this kind of value, okay, like this. But you cannot store any float value or character value into this. That means in a particular array, if you can store only a single type of value. Here the array has been declared as an integer, so here we are being able to store only integer type of value. Although we are being able to store more than one value at the same time, here the name of the array is a. So using the array name and index, we can track all the elements, but only similar type of values we can store. Okay, now suppose if we want to store the details of the records of the students of a particular class, suppose in that particular class 50 students are there, and now we want to store the roll number, we want to store the student name as well as the marks obtained for a particular subject by each and individual student of the class. So we have to store 3 different things. Roll number will be of integer type, the student's name will be an character array, so it will be of character type, and the marks can be integer or it may be float also. So you can now check that now we have to store the values of different data type, integer, character, and then integer or float. So now the question is, how can we store this type of values? Okay, so to overcome this limitation of this array, now we are going to think about a data type that can hold these types, a heterogeneous type of data, different types of data. Okay, so now we are going to define structure. So definition. Now what is the definition of a structure? A structure is nothing but a user defined compound data type, okay, which can store the information or records related to a particular person or an item. Okay, so it is capable to store heterogeneous type of data. Now what is a structure? A structure is nothing but a user defined data type, compound data type, which can actually store heterogeneous type of data. That means at the same time it can store integer type of value, it can store float type of value, it can store character type of value. So any type of value, that means which are not of same type, heterogeneous type of data, it can store. Okay, so structure is capable to store. It is actually a user defined compound data type, user defined compound data type, which is actually capable to store heterogeneous type of value. Okay, so now we will check how to declare a structure. So declaration of a structure. Okay, so suppose you want to store the records of each and every student of a particular class. Okay, so if we have to declare a structure, there is a keyword available in C language and the name of the keyword is struct. So this is the keyword struct, 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 and this is the name of the structure. So struct student. So here this is the keyword and this is the name of the structure, student. Now we want to have 3 members in this structure. For example, roll number. So it is of integer type, roll underscore number. Then we want to store the student name, that is of character type. So it is in character array, sname 20. So it can store maximum 20 minus 1, 19 characters, because the last character will be null in C language. Okay, and suppose the marks obtained by the student. Okay, so these are the 3 members of the structure, and whenever you are declaring a structure, it must have to be ended by a semicolon. So after this closing curly brace, you have to put the semicolon, because a structure is a statement. Okay, now here the student, this is actually the name of the structure. Okay. And these 3 things are called data members or elements of the structure. Okay, so this is the name of the structure. Here the name of the structure is student, and there are 3 members, namely roll number, student name, sname, and marks. So this is the declaration of a structure. Now whenever we are declaring a structure, so until and unless we are not declaring the structure variable, we cannot access this value, because you cannot directly access roll number, sname, and marks, because these 3 things are the members of the structure. Now why this structure is called user defined data type? Because here I have decided, being an user, that I want to have 3 members. Okay, roll number, sname, and marks. Now someone else may decide to store 2 more fields, for example the student contact number and the student address. So what are the members of the structure, or how many elements will be there inside the structure, that will be solely, that is the sole discretion of the user to decide. Okay, so that's why it is called user defined data type. And why is it called compound data type? Because it is capable to store heterogeneous type of data. That means you can check that this is of integer type, this is of character type. That means different data types value we can store under a single variable name. So this is the declaration of a structure. Next point is declaration of structure variable. Okay, now we will declare the structure variable of the student structure. So how to declare the structure? You have to write struct, then the name of the structure, student, student, and then we will mention the name of the variable, for example s1, s2, s3, like that. So here what I have done, I have declared 3 different structure variables, namely s1, s2, and s3 of struct student type. So since these s1, s2, and s3 are the variables, so the next question will come that what is the data type of these three variables. So the data type is simply struct student. So S1, S2 and S3 are the variable of struct student type. Okay, similarly, so here what is S1? S1 is actually a particular student which will contain these three fields. Okay, similarly S2 is representing another student which will actually have three different fields. Okay, and S3 will be another student, will represent another student, and this student will also have these three fields, that means roll number, name and marks. Okay, now whenever these three variables will be declared, after executing this line by the C compiler, what will happen? It will allocate the memory for this structure. So how many bytes will be allocated? So you check that how many fields are there. There are three fields, and first one is the integer. So integer will take 4 bytes of memory. Then the S name, its size is 20, and character takes 1 bytes of memory. So for 20 it will take 20 bytes. So 4 plus 20, and the third one is also an integer type. So 4 plus 20 plus 4, so as a whole it will take 28 bytes of memory. Okay, so S1, for this S1 variable it will take 20 bytes of memory. S2 it will take another 20 bytes of memory, and S3 it will also take another 28 bytes of memory. Okay, but this 28 bytes of memory for a particular structure variable will be of contiguous. Okay, so there will be contiguous 28 bytes, and the first 4 bytes will be for roll number, the next 20 bytes will be for S name, student name, and the last 4 bytes will be for marks. Okay, so now we will check what will be the memory map of these structure variables. Okay, now we can check that I have already drawn the memory map. So here this structure actually taking 4 plus 20 plus 4, that is 28 bytes of memory. So suppose the allocation is starting from 1001, so it will end at 1028. So this 28 bytes of contiguous memory will be reserved for, suppose, for the structure variable S1. So similarly for S2 and S3, another 28 bytes and 28 bytes contiguous memory will be allocated. Okay, now out of this 28 bytes, since the first memory is roll number of this structure, and roll number takes 4 bytes of memory, so the 1001 to 1004, these 4 bytes will be reserved for the roll number, for first 4 bytes. Now from 1005 to 1024, this next 20 bytes will be for student name, that is S name. Okay, and 4 bytes, that is from 1025 to 1028. So this last 4 bytes will be reserved for the marks. Okay, so this elements, actually the structured elements, will take consecutive memory. Okay, so in a contiguous way the memory will be reserved for each and every individual variable. Okay, now here we have declared the structure variable. So 3 variables have been declared, that means 3 students data we can store. Okay, similarly if we have 50 students in the class, so definitely we will not declare S1 to S50, these 50 variables, because it will be very tedious job and time consuming job. So instead of mentioning the variables one by one, we will now declare an array of structure, that means called structured array. So how to declare a structured array? So we have to write the same syntax, that is struct student, and then instead of writing S1, S2 up to S50, we will just write S50. Okay, so here what is S50? S50 is a array of structure or structured array which can contain 50 structure variables of struct student type. That means the first structure variable will be of S0, then S1, S2, and the last structure variable will be S50 minus 1, because you know that the last index of the array is size minus 1. Here the size is 50, so the last index will be 50 minus 1, that is 49. So the structure variable will be starting from S0 to up to S49. So these 50 structure variables starting from S0 to S49 will represent a different student. That means S0 will represent the roll number 1, S1 will represent roll number 2, S2 will represent roll number 3. Similarly, the 50th students of the class will be represented by the structure variable S49. Okay, so this way we can declare array of structures. Okay, similarly here if we declare an array of structures, so this is containing actually 50 structure variables, and you know that each and every structure variable is taking 28 bytes of memory. So for this 50 structure variables, how much bytes will be occupied? 28 multiplied by 50. Okay, and this is simply 1400 bytes. Okay, so this 1400 bytes will be allocated in contiguous manner. That means first 28 bytes will be for first structure variable, that is for S0, then the next 28 bytes will be for S1, the next 28 bytes will be for S2, like that, and last 28 bytes will be reserved for the last structure variable, that means for the 50th students of the class, and this students is being represented by the structure variable S49. Okay, so this way the memory will be allocated for the structure variable. Okay, so we have checked that how to declare the structure variables and array of structures, but whenever you are declaring the structure, at the same time you can also declare the structure variables like that. So we have declared initially 3 structure variables, S1, S2, S3, and the structure array, that is S50. So just after declaring the structure, if you mention the structure variable separated by comma and put the semicolon, so you do not need to declare the structure variable separately. Okay, so at the time of the declaration of the structure, you can also mention the structure variables. Okay, now we will check that how to initialize a structure variables and array. Okay, so the next point is the initialization of a structured variable and array. Okay, now how to initialize the variables directly without taking the value from the user. So we have already declared the structure variable struct student S1. Okay, now how many fields? It has 3 fields: roll number, name, and marks. So suppose the roll number is 01, the name is suppose Orun. Now name is a string, so it has to be enclosed by a double quotation, and suppose the total marks obtained by the student is 92. So this is the 3 fields of this S1 student. Okay, now if you want to initialize S2, then you can mention the roll number 02, then suppose the name of the student is Borun and it has obtained 79. Okay, now the last one is S3, the structure variable. Suppose the roll number is 03 and the name of the student is Joy and the student has obtained 89. Okay, and that is the end of the initialization part. Okay, now if you want to take the values for this structure array, you can do it in the same way that I have done for the structure variable S1, S2 and S3. Okay, now this is the direct initialization. Okay, so next we will discuss that what are the different operators that can be used in a structure. So basically there are 2 types of operators available. The number one is dot operator. Dot operator. Now if you are declaring the structure variables like that, okay, that we have done already. So struct student S1, S2, S3, like that. So here these structure variables are of normal type, that means it is not a pointed type. So if you are declaring a normal type structure variables, if you are dealing with a normal type structure variables, you have to use the structure variable, then the dot operator and the name of the members that you want to access. So suppose I want to assign the roll number for S1 student. Okay, so the S1 student structure variable is S1, then you have to use the dot operator, then you have to use the structure member, that is roll number, and suppose you are assigning 01, that we have already done here. Okay, so this way you can also assign the value. So if you want to access any members of the structure, you cannot directly access it. That means you cannot write it like roll underscore number is equals to 01. No, it is incorrect statement. Okay, because roll number, S name and marks are the property of the structure. So if you want to access them, you have to take the permission from the structure, and the permission we are taking in terms of structure variables. Okay, so this statement is invalid. Okay, similarly, if you want to access the, or if you want to store the name of the S2 student, name of the S2 student means first you have to use the structure variable, then the dot operator, then name, that means S name. Okay, so S2 students S name will be assigned by Borun, B-A-R-U-N. Okay, and this is a string, so it has to be enclosed with a double quotation. Similarly, if you want to store the marks of S3 student. So S3 student means the structure variable is S3 and you want to access marks. So you have to write structure variable dot operator, then the structure member, that is marks here, and what value you want to assign? 89. Okay, so this is the dot operator through which you can access the structure members along with the respective structure variable. So syntax is structure variable dot operator and the members or the elements of the structure that you want to access. Okay, and the next operator is arrow operator. Arrow operator. Okay, the first one is the dot operator that we have already gone through, and the next one is the arrow operator. Now when this arrow operator will be used, suppose you are declaring the structure variable like that, struct student, okay, asterisk S1, then for example asterisk S2. So here I have declared two structure variables S1 and S2, and both of them are pointer type. Why pointer? Because these two structure variables are associated with asterisk symbol. Asterisk symbol means it is a pointer. So these are the pointer type structure variable. So if you are using the pointer type structure variable, so this time you have to use the arrow operator. So S1 arrow. Similarly S2 arrow. And if you are using a normal type structure variable, for example S1, S2, S3, asterisk symbol is not associated here, so you have to use the dot operator. Okay, and if you are using a pointer type structure variable, for example S1, S2, here it is associated with the asterisk symbol, so you have to use the arrow operator. So if it is a pointer type variable, arrow operator will be used, and if it is a normal type variable, dot operator will be used. Then you have to mention the respective member that you want to access. So S1 arrow roll number, and that is already you have assigned using dot operator, that is 01. It is similar. Similarly, if you want to access the student name, if you want to store, so S2 arrow S name will be Borun. Okay, so this way we can use the arrow operator. Okay, so my students, so today I have discussed about the definition of a structure, why the structure is required. Then we have discussed the definition, then the declaration of a structure, how to declare a structure, then how to declare the structure variables. Then we have checked how to initialize the structure variables as well as the array. Hey, okay, and then we have been familiar with two different operators, that is there are two operators, dot operator and arrow operator. Okay, now here you check that we have initialized the value directly. Similarly, if you want to take the values from the user, so you can call the scanf function. Okay, so we want to take the integer value, roll number, then string, and then marks it is. So for roll number it is integer type, that is format specifier %d, then student name it is string type, that is percentage is the format specifier, and then the marks obtained by the student. So marks it is an integer type, for format specifier is %d. Okay, suppose you want to assign the value, so what you have to write? Ampersand, then s dot roll underscore number, then s dot s name. Okay, and then you have to mention ampersand of s dot marks, s dot marks. Okay, so this way you can also take the values from the user. Okay, so here you can check that I have not used the ampersand operator in case of name, but for roll number and marks I have used the ampersand operator, because ampersand is identifying actually the address where the value will get stored. But in case of s name, what is s name? You check that s name is an array. Okay, an array name itself is an address, it is a pointer. So whenever you are using the array name, you do not need to explicitly mention the ampersand operator, because mentioning the array name itself is an address. So that's why ampersand is missing here. Okay, so students, I hope that you have understood the concept of structure that we are going to use widely in case of linked list, stack, queue. Okay, so thanks for watching. Please take care. Have a nice day.